In this video, we're going to talk about derivatives of exponentials. If we have a term exponential e to the power cx, where c is a constant number, then the derivative of that term with respect to x is going to be c times e to the power cx, where c is a constant number. It is also worthwhile remembering some of the properties or some of the basic properties of exponentials so that it will be easier when you perform derivatives. Let's look at our first example. If we have d by dx of the term x cubed times e to the power 2x, then we can see here there's two terms, x cubed and e to the power 2x, which we can refer to as f times g, so that we can perform product rule using this formula. So according to the product rule, we can say x cubed times derivative of the second term e to the power 2x plus second term times the derivative of first term, which would be equal to x cubed times the derivative of e to the power 2x would be your constant 2 would come here, and then e to the power 2x using this formula, plus e to the power 2x times derivative of x cubed. We know it's 3 times x to the power 3 minus 1. Recalling the basic formula of derivatives of polynomial function, where d by dx x to the power n equals to n times x to the power n minus 1. So this is the same case here, which would simplify to x cubed to e to the power e to the power 2x plus 3x squared times e to the power 2x. You can take e to the power 2x common, and in the bracket it will be 2x cubed plus 3x squared. Let's look at another example where we have a function 6 times e to the power x cubed. If we have to find the derivative of this function, then what will we do? Let's say this whole x cubed term to be u. Then we have u as a function of x equal to x cubed, and the whole function with respect to u would be 6 times e to the power u, right? So now, according to the chain rule that we studied in our previous video, we can say our derivative of f, any function with respect to x, can be derivative of the function f with respect to u, which is 6e to the power u with respect to u, times derivative of the variable u, which is with respect to x, and in our case is x cubed with respect to x. So the derivative of first term 6e to the power 4 would be our constant 6, e to the power u would be e to the power u times derivative of x cubed would be 3x to the power 3 minus 1. So which equals to 6 e to the power u times 3x squared. Simplifying that and then substituting the value of u, we get 6 times 3, 18 e to the power x cubed and x squared. Another example, let's say we have a term 2 plus e to the power minus x divided by e to the power 3x, and if we are to find the derivative with respect to x in quotient rule, our denominator term is e to the power 3x, then we find the derivative of numerator minus our term of numerator times the derivative of the denominator with respect to x, divided by whole square of our denominator term, right? Which equals to e to the power 3x times derivative of 2 would be 0. Here derivative of any constant 2 would be 0, and then derivative of e to the power minus 2x. Our minus 2 constant would come down, and then derivative would be e to the power minus 2x minus 2 plus e to the power minus 2x times derivative of 3 e to the power 3x would be our term constant would come down, and then e to the power 3x divided by e to the power 3x whole square, right? So simplifying this, we get minus 2 e to the power. Now if we go to basic properties of exponential, we can actually write e to the power 3x times e to the power minus 2x as e to the power 3x minus 2x. Similarly, we have 3 times e to the power 3x 2 plus e to the power minus 2x divided by e to the power 6x, which will be equal to minus 2 e to the power minus x, plus x minus 6 e to the power 3x minus 3 e to the power x. I'm just using the properties of exponential, divided by e to the power 6x. Now in the same example that we just did before, say we had 2 plus e to the power minus 2x divided by e to the power 3x. We had to find derivative. It was the same example as before, this one. Now say we don't want to apply quotient rule here, so we can simplify this term by using the basic properties of exponentials. I'm just trying to show you how important is the basic properties of exponentials here. So for this whole term, you can simplify this as 2 by e to the power 3x plus e to the power minus 2x by e to the power 3x, right? So this would be equal to 2 times e to the power minus 3x plus e to the power minus 2x minus 3x. So this is simply 2 e to the power 3x plus e to the power minus 5x. Now you can just simply find the derivative of this whole term, and it will be a lot easier. Instead of applying all those quotient rule, dividing and squaring all those, it would simply be 2 derivative of e to the power minus 3x. We have constant minus 3, and then e to the power minus 3x plus derivative of e to the power minus 5x. We have minus 5 e to the power minus 5x. So here's our result. This is minus 6 e to the power minus 3x minus 5 e to the power minus 5x. So if you simplify this whole term in our previous example, then we'll get the similar result here. So instead of going all through this quotient rules and everything, if you know the basic properties of exponential, then it will be a lot easier. Now, how would you compute derivative of this term e to the power 4x squared? So we have got this. We can assume, or we can imagine this whole term as a single term, and then put this back to a variable u, which is a function of x now, which is equal to e to the power 4x squared. Then our function would be, with respect to the variable, will be e to the power u, right? So applying a chain rule, we can say df by dx. I'm just using the same general formula. Our function f with respect to u is deu with respect to du times d, the variable u with respect to x, is e to the power 4x square divided by dx, which would be equal to e to the power u, derivative of e to the power u is e to the power u times derivative of e to the power 4x square. Let's say here in this term, this whole variable, let's put this whole variable into u1 equals to 4x square. Then our function f1 with respect to u1 would be e to the power u1 again. So again, applying chain rule to this term, we have d f to the power u1, sorry, f with respect to u1 is e to the power u1 with respect to u1 times derivative of variable u1, which is 4x square with respect to x, right? So we can substitute the value of u, which was e to the power 4x square, so this is a square, times derivative of e to the power u1 is e to the power u1 times derivative of 4x cubed would be 4 times 3 would come down, and then x would be x to the power, so this is 2 minus 1. Now simplifying and then substituting the value of u1, we have e to the power 4x square times e to the power u1 is 4x square times 12x, right? I think I made a mistake here. I'm gonna correct this one. Sorry, this was 2, and then so this would be 2 as well. It just looks like 3 here. This should be 2. So this should be 8. Now our final answer would be 8x e to the power. Using the basic properties of exponential, we can write this as e to the power 4x square plus 4x square.